Hello class, so we're going to do synthesis problem number 1. The problem says, it's on page 122 of your text, suppose that two horizontal forces are acting upon a 0.25 kilogram wooden block as it moves across a laboratory table. Alright, so we got our table, we have our block. We know the mass of the block is equal to 0.25 kilograms. We have a 0.5 Newton force pulling the block and a 2 Newton force, frictional force, opposing the motion. Remember, friction always opposes the motion. So here we got our applied force. The force is equal to 5 newtons. And we have a frictional force opposing the motion. Remember, friction always opposes the motion. The frictional force is 2 newtons. That's the setup. The block moves a distance of 1.5 meters. The block moves 1.5 meters. Notice that I'm making the block move in this direction to the right. Why is that? Well, friction's going to left, and friction opposes the motion, so the block must be going to the right. And the amount that went is 1.5 meters. All right. First question, A. What is the work done by the 5 Newton force? So for A, we have our formula. We want the work done. We have a formula for work. Work is equal to force parallel distance. So that's how I'm going to write that. Force parallel distance. That means parallel. So we plug in. The force is 5 newtons. It's in the direction that the block is moving. So we write down 5 newtons. The distance it traveled is 1.5 meters. The author told us that. So 5 times 1.5 is 7.5. The units are Newton meters, but we've said that Newton meters are going to be called joules. So it's J, joules. So that's our answer. That's our work done for part A. The work done by the 5 Newton force. Now B, what is the work done by the net force acting upon the block? What is the work done by net? So we can say work done by the net force. Well, we got to find out what the net force is. Well, the net force is the sum of the forces. Forces are vectors, so we have to add them vectorially. So we subtract them. 5 going this way, 2 going that way, the result is 3, right? So F net is equal a positive 5 newtons to the right. Remember in class we defined to the right to be positive and to the left to be negative. So minus 5 newtons minus 2 newtons equals 3 newtons. All right, rocket science there. So the work done by the net force is equal to the force, in this case it's the net force, parallel distance. So the net force we've discovered is 3 newtons. And the net force is in the direction that the object is moving. And it's also moving, once again, it's moving 1.5 meters. So the answer is 4.5 Newton meters, but we've said that Newton meters are going to be called joules. So that's the work done by the net force, or work net. All right, question C, part C. Which of these two values should you use to find the increase in kinetic energy of the block? Well, we've learned that the net force done is equal to the change in kinetic energy. So let's just see. So which of these two values should we use to find the increase in kinetic energy of the block? We should use the net. We should use the net. Part D is probably going to be calculate the change in kinetic energy. I don't know. Let's see. Oh, so what would the answer be? The answer would be you would use, the work that you would use would be equal to the 4.5 joules. That's the answer. D, what happens to the energy added to the system via the work done by the 5 Newton force? Can it all be accounted for? So that's D. Well, part of the work done by this 5 Newton force is used to increase the kinetic energy. How much of this 5 Newton force is used to increase the kinetic energy? Right here, 3 newtons. The net force is used. This frictional 2 Newton force fights against the 5 Newton force, holding it back, so to speak. So the entire, let me see the question again. Can it all be accounted for? Well, yes, it can all be accounted for because we can do these separately. We can say the work done by the 5 Newton force gives us 7.5 joules of energy. The work done by the 2 Newton force then would be force times distance, 2 times 1.5 or 3 joules, but that would be a negative because remember, forces are vectors. So the work done by the 2 Newton frictional force would be 2 times 1.5, but to the left. So that would be a negative 3. So the work done by the 5 Newton force is 7.5. The work done by the 2 Newton force, the frictional force, is 3 joules. So 7.5 joules minus 3 joules is 4.5. So what happens to the energy added to the system via the work done? Well, the answer is used to increase the kinetic energy of the block. Can it all be accounted for? Yes, in an analysis. You have to do each one separately, add them together, and you can show mathematically that all the forces are accounted for. E, if the block started from rest. All right, E, I was wondering about that. If the block started from rest, so V0 equals 0. The block starts from rest. What are the kinetic energy and velocity at the end of the 1.5 meter motion? So it starts from rest. So initially, the question doesn't ask for initial, but we really have to find the initial to know what the final is. We know that kinetic energy is equal to 1/2 mv squared. Therefore, the initial kinetic energy is equal to 0 because the initial speed is equal to the 0. The author told us that the initial velocity was 0. And it also wants to know the initial speed. Well, again, the author told us what the initial speed is. It's equal to 0. And now what about the end? The block started at rest. What is kinetic energy at the end? Well, we can use our formula. Work net is equal to the change in kinetic energy. So work net, we know, is 4.5 joules. That's equal to the change in kinetic energy, which is kinetic energy final minus kinetic energy initial. Running out of room, so I'm going to go this way. Kinetic energy final, would this be 1/2 mv squared final minus kinetic energy initial? Well, we already said the initial kinetic energy is 0. So this is just equal to 1/2 mv squared. So if we know what the kinetic, so if we know what the final kinetic energy is, we can determine what the final speed is. But we know what the final kinetic energy is. It's 4.5, right? 4.5 is equal to the final kinetic energy. So we can write down our equation. 4.5 is equal to 1/2 mass of the block is 0.25. That was given. So we can put in 0.25 times v squared. V squared. One equation, one unknown. We eat them for lunch. So we do a little bit of math and we come up with v final is equal to, well, 4.5 times 2 is 9. 9 divided by 4. I'll use my calculator. Don't have Brandon to pick on. So 4.5 times 2, and then, well, divide by 0.25 or multiply by 4 equals, that's 36. So the square root of 36 is equal to 6 meters per second. So now we know what the final, kinetic energy is, 4.5 joules. And we know what the final speed is, 6 meters per second squared. And that is question 1. This was question 1 for chapter 6. Okay.